James and Tyler have been friends for 10 years. In this past week, they've set out to accomplish one goal: create a beam out of corrugated cardboard that could hold 250 pounds. Day one was pretty easy. We learned about the project and the steps that it would take to complete it. The first step that we completed in day one, completing a partnership agreement. Everyone's partner agreement had to be unique. For ours, we made it so that James would be working on the video and Tyler would be working on most of the fusion work. We also knew ourselves too well, so we banned any talk of discussing NHL during the project. How do you feel going into this project?
I'm feeling pretty good about it. My whole plan kind of revolves around making corrugated cardboard out of corrugated cardboard and just making a big corrugated cardboard beam. And I think it's going to work and it'll be pretty cool.
How are you feeling about it, James?
I'm feeling pretty good about this project. I think me and Tyler are going to make a good team together because Tyler is really good at the design aspects of projects, and I feel like I'm pretty good at forming the documentation together, so I can leave the creative stuff to Tyler and work on the more practical stuff that needs to be turned in.
What are your thoughts on cardboard?
You know, I'm such a huge fan of cardboard. I've been surrounded by it my whole life. I've grown up with cardboard, and I'm just really looking forward to the opportunity of working with cardboard because this is the first time I've done it in a while.
On day two, I wasn't at school because I was in Columbus watching Stars game. Go Stars! But in the meantime, Tyler started working on the corrugated cardboard report. As with any material, you have to have a full understanding of what it is and how to use it to optimally use it in a project.
How are we able to use the research that we took and put it into our project?
So one thing that we learned was that corrugated cardboard has two outside layers. It has the outside liner and the inside liner. The outside liner is tougher than the inside liner. So when we're making our beam, we're going to want to have the outside liner on the outside. And we can use that to our advantage by making the outside tougher than the inside because it's the outside that's going to be taking in the initial impact of the pressure. This time, it was Tyler's turn to not be here. He was at a college visit in Cincinnati. But while he was gone, I organized all of our papers into one single folder so it can be turned in easily. While he was also at Cincinnati, he and myself were also working on our designs for our beam. This is not the original drawing. This is just a drawing made to demonstrate how the pressure would be applied onto each beam. This is design one. It has 3 pillars down the middle with 2 beams sandwiching it, so the pressure would be applied equally to all 3 beams. This is design number 2. It has a zigzag pattern inside of a box, so when the weight presses down on top of the box, it's going to be evenly applied to this beam, and it kind of makes a corrugated cardboard out of corrugated cardboard, kind of like how Tyler mentioned in the intro of this video. This is the third design. This one is probably the most optimized for weight, but this is kind of like a side view of it. So when the weight presses down, it will push down on a middle beam and 2 side beams. This design would be repeated a bunch of times over. This is just one little design made for the purpose of this video. This is the final design that was made, and it was made because I didn't realize that we needed 2 designs. I only made 1, so this is one that I threw together very quickly, so it's not very well done. But essentially, it would have 1 beam coming across the middle, 1 down, and the other 1 down for where the pressure is going to be applied if it was put on the top. With 4 designs, we had to take it to a design matrix. We measured many things around design matrix, but the 2 things we paid most attention to were the weight and the strength, because we believed that those were the 2 most important categories. Before we could create the actual beam, we had to make it in a design software called Fusion. In our Fusion, we had to make each individual part. For this, there were 4 different parts: an end beam, a support beam, 2 cross beams, and a top and a bottom layer. Each part needed to be individually dimensioned and added together into one assembly. In this video, you can see us walking to the printer to print out our pictures. What are your thoughts on how we did?
I'm pretty happy about how we did. When we were actually testing it, I think we would have gotten a lot further if the little support beams, they were actually like vertical instead of horizontal, how they were supposed to be. And I feel like that made a huge impact on like the wobbliness and stuff of our design. But I'm still pretty happy of how we turned out. We managed to hold 233, and we had the lightest beam in the class.
Go.
I think we did pretty well on our beam, kind of like how Tyler said. I think we would have had it better if the beams were sideways, because I think the big problem is that when it deflected, it pushed the beam out from under it. But hindsight's 2020. I think if I could change one thing, I think I'd make our beam an extra 2 inches longer, but that would have added weight. And I think a main goal that we had going into this was to have one of the lightest beams, which we did. So overall, I'm pretty happy with it. Thanks to our focus on trying to keep our beam the lowest weight possible, we weighed less than all the other groups. And because of that, our weight held to weight ratio was less than everyone else's, giving us the victory. All that was left to do after that was to gather up our final materials and turn them in.